Let's look at our number 2 circuit. Looking at my given material here, I have a source voltage of 4 volts. R1 is 8 ohms. R2 is 4 ohms. And R3 is 12 ohms. We're going to start out finding the total resistance for the circuit, R sub T, and the formula for resistance, total resistance, is R1 plus R2 plus R3. So we plug in our numbers. For R1 is 8 ohms, R2 is 4 ohms, and R3 is 12 ohms. We add those together and we should get 24 ohms. Next, we're going to find the total current. Ohm's law for total current is voltage divided by resistance. Since I'm looking for total current, I'm going to use the source voltage, and I'm going to divide by the total resistance. So the source voltage is 4 volts. Total resistance is 24 ohms. And that's going to give me a total current of 0.167 amps. If I convert this to a number using a metric prefix, I would move the decimal point 3 places to the right. That would give me 167 milliamps. Next, I would ask you to determine the current through resistor R1, through the resistor R2, and resistor R3. And you would tell me that in a series circuit, the current remains the same at all points in a series circuit. So the current through R1 would be equal to the current through R2, which would be equal to the current through R3, which is equal to the total current of 167 milliamps. Next, we're going to find the voltage drops. The voltage drop across R1 is going to equal the total current through R1 multiplied by R1. So the total current we know is 167 milliamps, and that's going to be multiplied by R1, which is 8 ohms. And if I multiply 167 milliamps times 8 ohms, I should get 1.34 volts. VR2 is the total current multiplied by resistor 2. So that's 167 milliamps multiplied by R2 of 4 ohms, and that equals 0.67 volts. And VR3, same formula, total current multiplied by R3, got 167 milliamps multiplied by R3, which is 12 ohms, gives me a voltage drop of 2 volts. Then if we verify Kirchhoff's voltage law, I would take the voltage drop across R1 plus the voltage drop across R2 plus the voltage drop across R3, add them together, and it should equal close to the source voltage. So VR1 is 1.34 plus VR2, which is 0.67, plus VR3, which is 2, and that adds up pretty close to 4 volts.